Welcome to EduCasts, home of EduCasters. 4. Jerome Bruner, The Spiral and the Story. Jerome Bruner, another American psychologist, provided a brilliant bridge between these ideas. He coined the term scaffolding to describe what a teacher does in Vygotsky's ZPD. He also championed discovery learning, a direct application of Dewey's ideas. But Bruner's two biggest contributions were the spiral curriculum and the power of narrative. Bruner argued that any subject could be taught to any child at any age, as long as it was presented in an intellectually honest way. This was the spiral curriculum. You don't teach physics once in 11th grade. You teach it in 1st grade by letting kids play with rants and balls, an enactive or action-based representation. You teach it again in 5th grade by drawing diagrams, an iconic or image-based representation. And you teach it again in 11th grade with formulas, a symbolic representation. Each time, the student spirals back to the core idea, building a deeper and more complex understanding. More importantly, Bruner emphasized that we don't just build schemas, we build stories. He argued that our minds are narrative machines. We don't just learn facts about history, we make sense of them by fitting them into a story of progress, a story of conflict, etc. An education that is just facts and formulas will be forgotten. An education that helps students construct meaningful stories about themselves and the world will last a lifetime. A tale of two classrooms. So what does this all mean on a regular Tuesday morning? Let's compare two 4th grade classrooms, both teaching ancient Egypt. In classroom A, the transmission model, the desks are in straight rows facing the teacher. Miss Smith is giving a lecture with a slideshow, instructing students to write down facts like, the Nile River was the lifeblood of ancient Egypt. The work consists of quiet note-taking, followed by reading a textbook chapter and answering the questions at the end. The goal is to memorize key facts about the Nile and pharaohs, and the assessment is a multiple-choice test. The philosophy is clear. Knowledge is a set of facts, and the teacher's job is to deliver them. In Classroom B, the Constructivist model, the room is arranged differently. Desks are pushed into ponds for 4 to 5 students, and the walls are covered in their work in progress. The teacher, Mr. Brown, introduces a single driving question. How would you survive in ancient Egypt? The room is buzzing. One group, the farmers, is researching the Nile's floods to figure out when to plant. Another, the engineers, is trying to build a stable pyramid model, discovering principles of geometry. A third, the scribes, is inventing their own hieroglyphics. The goal here is not just to know facts, but to understand the problems the Egyptians faced. The assessment is a group presentation of their survival guide, graded with a rubric that assesses their problem-solving and teamwork. But let's look closer at Mr. Brown. He isn't just sitting back, he's circulating. He kneels beside the engineers whose tower just collapsed. Wow, that went down fast. What did you notice? Where did it seem to fail first? What do you know about building a strong base? He's not giving them the answer. He is scaffolding their thinking with questions. He visits the farmers. Interesting, your group decided to plant all your crops at once. What did your research say about the length of the flood season? What might happen to the crops you plant too early? He's pushing them into disequilibrium, forcing them to accommodate this new problem. Mr. Brown's job is infinitely harder than Miss Smith's. He is a diagnostician, a facilitator, a co-conspirator, and a master question asker. This classroom is messy and noisy, but the learning is deeper and more permanent. The students in Classroom A will forget the facts, but the students in Classroom B will remember what it felt like to solve the puzzle. Is Constructivism really the best way? This all sounds wonderful, but Constructivism is not without its critics. To be a truly excellent educator, you have to grapple with the tough questions and the real-world challenges of this philosophy. The biggest criticism is that a constructivist classroom is just fluffy. Critics argue that in the rush to do fun projects, the basics are lost. Kids are just playing with cardboard and not learning to spell, one might say. This is a fair critique of bad constructivism, which is a free-for-all. But good constructivism is the opposite. It is highly structured, requires meticulous planning from the teacher, and is often more rigorous than a traditional class. Mr. Brown had to plan that project for weeks to make sure the engineers would run into the geometry problems he wanted them to solve. He didn't just let them play. He guided their play toward a specific learning goal. A more serious critique comes from cognitive science, often called the expert versus novice problem. It turns out that beginners and experts learn in very different ways. An expert, like a history professor, can discover a new theory from a document, but a fourth-grade novice doesn't have the background knowledge to do that. If you just let them discover, they'll get lost, frustrated, and build the wrong mental maps. This is where cognitive load theory comes in. This theory argues that our working memory, the mental space where we actively think, is tiny. Discovery learning can completely overwhelm this working memory, imposing a high cognitive load, because the novice student is trying to juggle two things at once: the process of problem solving and the content they're supposed to be learning. In this view, for novices, direct instruction, like Miss Smith's lecture, is actually more effective because it reduces cognitive load, allowing the student to build those first basic schemas in their long-term memory. You can't discover how to read. Someone has to directly teach you the letter sounds. This leads to a third, philosophical problem. What if a student constructs the wrong idea? If a student, through their own discovery, becomes convinced that a heavy object falls faster than a light one, a very common intuitive construction, what is the teacher's role? Does Mr. Brown step in and transmit the correct answer, Newton's laws? If he does, he breaks the pure constructivist model. But if he doesn't, he is allowing the student to build a mental map that is factually wrong. This is the central paradox of constructivism in a world that has correct answers. The final critique is one of pure practicality and equity. Constructivist teaching is hard and expensive. It takes time. A project might take 3 weeks, whereas a lecture takes 2 days, a difficult trade-off in a world of high-stakes standardized testing. It also takes resources, like computers, art supplies, and most importantly, small class sizes. It's almost impossible to be Mr. Brown with 38 students in a crowded room. This can also be an equity issue. Students from privileged backgrounds often come to school with a wider range of experiences, vocabulary, and cultural capital, giving them a head start in discovery and project work. A project to build a model of your community might be easy for a child with a big house, Legos, and parents who can help, but a source of shame for a child in a cramped apartment. Furthermore, how do you fairly grade a group project? What about the hitchhiker, the kid who does no work, or the hijacker, the kid who does all of it? These are real, on-the-ground problems. So is constructivism the one true way? No, it's not a silver bullet. The transmission model of pure, direct instruction is not all bad, and pure discovery learning is not all good. The best teachers in the world are not dogmatists. They are pragmatic, skilled professionals who have a whole toolbox of strategies. They understand that constructivism is not an either-or proposition. It's a both-and. These teachers are what we might call balanced builders. They use direct instruction to give students the bricks, the foundational knowledge, the facts, the vocabulary, and the formulas. They know that novices need this. As cognitive load theory suggests, they transmit the letter sounds, the multiplication tables, and the basic timelines of history. They know that a student can't build a house without a pile of bricks, but they don't stop there. They know that a pile of bricks is not a house. They immediately use constructivist projects and driving questions to challenge students to use those bricks. They ask students to take the facts, the formulas, and the vocabulary and build something new, meaningful, and personal. They ask them to apply their knowledge to solve a real problem, to write their own story, to debate a real issue. Constructivism's greatest legacy is not that it gave us group projects. Its greatest legacy is that it fundamentally changed the conversation. It forced us to see the learner not as a passive, empty jar, but as the single most important, active, and powerful force in the classroom. It reminds us that you can teach all day long, but no learning happens until the student picks up their own tools and starts to build.